This problem deals with a scenario where we're given an array of positive integers, and we can perform two types of operations repeatedly. Choose set y elements with equal values and delete them. Choose 3 elements with equal values and delete them. The goal is to find the minimum number of operations required to make the array empty. If it's not possible to empty the array, we should return -1. The answer is explained as follows. Let's start by counting how many elements have the same value in the array. Let's call this count CNT. If there is any element in the array with CNT equal to 1, meaning there is only one element of a specific value, we can't empty the array. This is because, in order to use either of the two operations, we need at least 2 or 3 elements with the same value, respectively. So, if there's an element with a count of 1, it's impossible to perform any operation, and we return -1. If there are no elements with CNT equal to 1, we can empty the array. To do this, we remove elements in groups of 3, as this is the most efficient way to use the available operations. If the count of elements with the same value is divisible by 3, CNT% 3 equals 0. We can delete all elements with the same value using CNT3 operations. If there is a remainder after division by 3, CN3 greater than 0, it means there are some elements left after removing as many triplets as possible. In this case, we first remove elements in pairs 2 at a time to minimize the number of elements with a remainder of 1. We need 1 operation for every pair 2 operations for each remainder of 1. After that, we can continue removing elements in triplets. This is why we add 1 to CN3 in such cases. This approach ensures that we use the minimum number of operations to empty the array, and it takes into account the constraints of the problem, such as not being able to delete single elements.